हरि करना।
Welcome to the first part of third module, that is networking, an introduction to the networking of iDevOps for You course. iDevOps for You course is completely free. It is not at all chargeable, and I'm using all my resources to the full extent, my time and my other knowledge related resources, just to make uh, a small positive difference in your knowledge gaining. So now in this module we are going to talk about a very important concept. If it is not there, so whatever activities we want to do, either it's ML ops or DevOps or artificial intelligence, it is those activities won't be possible at all. So that concept is nothing but a networking. So without networking, so a lot of things are absolutely impossible. So that's the reason I just want to give more stress on networking before we enter and explore uh, into the more important topics in DevOps, such as Git, Docker, Kubernetes, Jenkins. So all these things, even whatever you want to do with all those tools and the activities that are related to those tools, you should able to understand a networking concept. So that is the reason. Let's explore networking first, and then we will move into other topics one by one in our next module. So if you look into the screen, you can see on rightmost one trick, or you can consider it as a software hack. So please do not tell secret password anyone. So P, physical layer; do, data link layer, not network layer; tell, transport layer; S, secret, that's a session layer; P, presentation layer; A, application layer. This is how we used to remember. With this kind of hacks we used to remember in our engineering days, so that we can get good amount of marks. But now we are not here to get good amount of marks. Now we are here to get good amount of exposure to the networking. So that's the reason. In spite of going with the hacks, let's focus on the substance. So networks are everywhere, or so it seems. You can do anything with data that does not involve a network. So you can hardly do anything with data that does not involve a network. So like the human networks, that we are all a part of a computer network, that is share information and resources. For example, in business, the reliance the reliance on networks is even more pervasive than in homes or schools. So networks help individuals and businesses alike save money, but they also create income. So without a doubt, networking within the home will catch on over the next few years, as it has in business. Soon, nearly all individuals in even moderately developed nations will have networked components throughout their homes. So that don't those that don't follow this networking, uh, will be netologically disadvantaged because they will not be able to learn or to function at the same level as those who are networked. Networking, everything is all is about network, only about network, only about networks here. Okay, so now we will begin networking module with human networking analogy, and we will take up networking models and each layers in it consequently. So in its broadest sense, a network consists of two or more entities or objects, whatever way you wish to call, or you can also say it as a sharing, basically two or more entities or objects sharing resources and information. That's what a network. So although this module is about computer networks, there are networks that don't involve computers, and those networks are everywhere. So you have grown accustomed to accustomed to working with these kind of networks, possibly without even knowing it. So that's my job, to make you aware of these networks, and from this moment you're going to be conscious about these networks too. So it may not matter to you that, in a basic sense, sharing, either giving or getting, is a fundamental aspect of networking. That is the main principle of networking. Sharing, either a giving or a getting, is a fundamental aspect of networking. So you just know that. Now you will do it. So let's begin with our first human network, that is a family network. So most people belong to a family network in which related people share their resources and information. This sharing is bidirectional because even the youngest family members share information of some sort. As the family grows, so does the network. So here is a network which connects members of a family together, where resources, knowledge, experience, information will be shared in between. It's exactly in front of your eyes on your screen. So this is how a family network works. So if you see a father, a mother, a child, and child one and child two, it may be young or it may be boy or girl. So whatever it may be, so there is a clear cut sharing of resources between each member of the family. So it may be a financial terms, or it may be knowledge based, or it may be experience based, or it may be some information based. So whatever it may be, there is a clear cut give and take between each and every family member of that family. So that's why I call this network as a family network. So this is the best example for a human network. So as soon as you're born, you are part of a network. You are a part of a network. So whether you know it or not, you will always be in a network. As you grow up, kids network. As you grow up, school network. As you grow more up, then you will become a uh, engineering network. Then at this moment you're in social networks. Just kidding. Okay, so then So the next network that you will be part of when you're reaching at the age of 25 or 24, so when you started working, that's your peer network. It can be even in school. It's a peer network. So peer network outside the family, there is a community that offers a wide array of resources than the typical family can provide. Naturally, it makes sense to connect the family to this community to take advantage of the wealth of resources available around around it. So if you see the following example that is displayed on the screen, so this type of information or resource sharing can be as simple as loaning a hammer to a neighbor, or carpooling with work associates, or helping a friend with his or her homework. So all of these activities involving sharing or trading resources. So this kind of network is represented by a two-way relationship, a give and take among equals or peers. So this is a family network. Once you come out of your house, then you have to set up a peer network, one more network. So there you have to get in touch with the school, hospital, work, store people, so that you can basically have that give and take relation, so that you can get more information to sustain your life, to live your life, to enhance your life quality. So that's the next network, that's a peer network. So now let's take from the peer network, from the home you went to a restaurant to eat up, to dine up. Let's see what kind of network there you can find. So so in any type of human network, there is a lot of giving and taking. You're already more accustomed to the client or server perspective in networking than you realize. So for instance, because you might have heard that client and the server concept, that's how our web applications are hosted. Most of the web application, even few software such as Docker also works on the same logic, the client and server, Docker daemon, and then Docker engine, a Docker daemon, and then Docker client. So we'll have a two softwares that basically make this containerization possible. So the client and the server, you think this is the concept, it's just related to the software or networking? No, no, my friend, not at all. From childhood, you had been encountering this the client and the server model, and you were also the part of this, the client and the server model. You may ask how. I will tell. Don't worry, my brother. So, uh, networking, then you realize. So now let's take one example. For instance, when you go to dinner at a restaurant, you become a customer, obviously, or a client, enjoying the food and drink prepared and served to you by the restaurant. On the other hand, the waiter works as a server, controlling and providing his customers with access to resources in the form of placing orders for the for and delivering food items. So here, in this case, in this example, uh, the server is our server and the client is you, the family members that you have gone there to dine up. So the server knows that requests will be made of him. So it's like access is sought when the order is placed. and then he will service those making the requests. So whatever request that you have made from your family, your for example, you have asked for you want juice, and for your wife roti, and for your kids idli. So you have made three requests, and all three requests will be served by the server. We don't care what's happening in the back end. We are only cared about the server and then customer or the client, the transaction that's taking place between the server and the client. So the client and the server, this is what the client and then server. So once uh, the server knows the requests will be made of him, so uh, once the requests have been made, so he will service those requests who are making, and then that means literally in this case he will deliver the orders that they placed that they have placed. So anyone who has looked for a job knows that one of the best ways to find a job is to network. So that is to create a list of friends and associates who will help you find the perfect job. The more people you meet and get to know, the better your chances of obtaining a work. So as you develop and nurture your career, this contact network will serve you best, because your role in it will change as you gain more experience. So soon you may be able to help the people who helped you, and as your personal and professional network grows, so your opportunity grows. So if you see all these examples of human networks should help you understand that networking is common between people and is not just an activity restricted to computers. However, this module will focus on only computer networks, connecting computers and having them communicate with each other. So before I close up this slide, I would like to give one small information, a disclaimer, or maybe a caution. So the caution is you must be very careful about this contact networks. Basically, the networking sales. In India, it happened with my friend, my best friend. So basically, somebody has approached him. His best friend had approached him to join in that contact networking sales. So they came up with a small product, and uh, if he able to make up a network with that product, so he will become a rich. That's what the condition. That's what the business that's what the business uh, model of that. So then this guy joined in that, and approximately he lost 2,50,000. So then after 1 year he got to realize that okay, there is some scam going on around. It's time to sue. It's time to get out of this. Get out of this. So then immediately we spoke, and then we started asking for the money, and we have sent mail, but he did not get the complete money. He did not get the complete money return back, whereas he got around at least 1,50,000. He lost 1 lakh. So that's why just be careful. Mm, don't basically don't become greedy for the money. So money is not just the life. Okay, so you do what you enjoy most. I enjoy software and then applications related to it, and the tools that are related to it, and learning new tools, new techniques, and then if it is possible, teaching fellow mates and friends and everybody. So I'm doing it, so money will fall in place, so you don't need to worry much about that. So don't fall for this kind of greedy offers. This is my suggestion. So now let's look into actual computer networks. A computer network consists of two or more computing devices that are connected in order to share the components of your network. Basically, what are the components? It's resources. So, and the information that you store in that computers. So, as uh, as you can see that in the infographic, which is exactly in front of your eyes on your screen. So we have two computers, one personal computer and one laptop, and then we have one printer is an output device. So you can see the you can see the infographic that's displayed on the screen. So the most basic computer network, which can just consist of just two connected computers, and from this it can expand and become more usable when additional computers join and add their resources to those being shared. So in this case, the first computer is yours, is commonly referred to as your local computer. It's more likely to be it's more likely to be used as a location where you do work. So you normally we call it as a cubicle or workstation. So then as a storage or a controlling location or a server. As more and more computers are connected to a network and share their resources, the network becomes a more powerful tool, because employees using a network with more information and more capability are able to accomplish more through those added computers or additional resources. That is the reason. And networking always enhances your capabilities or skills. I'm talking for human. Of course, the same applies to the computers. Sometimes it affects in a negative way also for humans. Same happens with the computers also, but we have to see the positive side, the brightest side of networking for this moment, and then after that we will move into negative side of darkest side of the networking. So how can you solve that? That also will do it. So now the real power of networking computers become apparent if you envision your own network growing and then connecting it with other distinct networks. So enabling communication and resource sharing across both networks. So that is, one network can be connected to another network. So one network can also be connected with the another network and become a more powerful tool because of the greater and very higher amount of resources that can be used across the networks. Basically, the opportunities are growing to enhance your abilities and skills. So now identifying the benefits of network. After knowing the fundamentals of network, you all might be pondering around the question, what are networks used for? And this is a simple question. What are the networks used for? Why do you need it? Before I address this question, I would like to take you through a small historical story, a small history story. So, in the early days of the personal computer, around during the late 70s and early 80s, at that time, not now. So, at that maybe 40 years back, often a PC was used as a stand-alone computer and operated independently from other computers. So, when over the span of just those few years, their use proliferated and more pieces, more and more pieces were found relatively close to each other. So, users began sharing information. So the information was either printed out or copied from. You have only two options: either printed out through through the printer. That's our output device, or one either printed out, or the second option you can have is just copied from one computer to another using backup or storage devices such as tapes, disks, or other kind of digital storage media. So some so now the printout or the storage device was then physically carried to another computer where the information was re-entered or copied from the portable media into the next computer. So this process was referred to as a sneaker net. SNEAKERNET, sneaker net, because user actually had to walk from one computer to other computer. So it was probably the cheapest type of network, unless the computers were large distances apart from the information needed to be shared among many computers. So other drawbacks to sneaker nets were that printouts were often bulky and the storage devices could hold a relatively small amount of data compared to the large amount of output users produced. So with this condition, so once computers were connected by networks, so information sharing increased dramatically. So people found that more data helped them make better decisions and companies started saving money. So many original networks were designed to facilitate communication. That's it, nothing else. That was their initial motto, basically, to work on or design networks. So, but they were quickly expanded as businesses noticed increasing productivity and reduced costs because of this network. So that's how that's the way the networks helps us. So okay, enough of history lesson. Now let's get back to the benefits of a network. So what are the benefits of network? The first benefit is sharing information. What's the sharing information everybody is doing? So fundamentally, we whether it is a human network or a computer network, the fundamental reason for establishing a network is sharing network. So the initial reason or the main reason for developing most computer networks was to assist users with sharing their increased output, especially between computers in the same general vicinity. So also individual employees are more likely to communicate with larger numbers of individuals, both inside and outside of the company, using email or an electronic means of communicating that's similar to mail but done on computers, so usually over the internet or over the networks. So email is the most commonly used feature of the internet, and its use is growing dramatically. In fact, email is fast becoming the primary choice for much of our daily communications. And the second benefit that we have is resource sharing resources. So is the sneakernet in the sneakernet era, that's early 1970s and 1980s. In that sneakernet era, users spent huge amounts of time attempting to share their resources. They had to physically distribute files that others needed, and expenditures for printers and others attached computer components rose rapidly, while the individual components themselves were not being used to their full capacity. On top of that, the hard disk storage on each local computer began filling up, partly because everyone had a copy of every document. That's the biggest pitfall of it. Uh, then the ability to share resources was another reason networks were created, and it is still one of the main purposes of using networks. So companies also look for ways to make the best use of their investments by sharing the purchased resources among multiple departments. Let's look at some of the resources that are commonly shared over computer networks. The first one is peripherals. Peripherals, basically printers, scanners, and speakers. So basically these are the things which we want to share across in multiple departments. Printers, if you're part of a corporate company, or a corporate employee, you might have known about this. So then storage. Then we have a storage. So storage, a user quickly ran out of space on their own local computers. So the people in charge of the networks began advising ways to store data centrally, so that it was accessible to any user who needed it. And one more resource which can be shared across the departments is applications. Users quickly ran out of space on their, so because of this, storage is also one of the biggest issue. But however, the applications are the one which can be shared across. So for example, if you take one example, so most of the company, if you're part of the corporate company, so all the applications can be shared across departments. And of course few applications are specific to design department, few applications are specific to commercial department, few applications are specific to HR department. However, the applications which are HR related applications are used commonly by everybody, all the employees. And applications such as those used for preparing taxes, creating text documents, or playing computer games have grown in the complexity and size, and often take up considerable local storage. So installing an application once on a network and then sharing it cuts down on the storage space required when multiple users need this application, because these applications are needed by every employee of that company. So that's the reason it shares a huge amount of huge amount of resources for the owner of the company. Then assisting collaboration. So once you have digital information and the ability to share it instantly with others over network. You can have multiple people working on the same process collectively, or same project, and Word, Access, Excel, and PowerPoint. These kind of tools can be used collaboratively. Of course, that's what is happening now. Git is one of the tool where we can work collaboratively. So allow multiple users to access and make changes to the same document in the same time. Example, Excel, we have uh, PowerPoint. We can connect it through Microsoft Office 360, and Power BI, we can do it, and even Tableau, we can do. The dashboard can be edited centrally. So finally, facilitating centralized management. So what does it mean? It brings a lot of savings using economies of scale, and reduces the total cost of ownership, managing software, maintaining the network, and backing up the data. So these are the benefits. However, because of this economies of scale, so there will be huge amount of reduced total cost of ownership. That makes a huge difference for enterprise owner. Now let's look into various terms of the computer network. Basically, basic terminology used in the computer network. Let us begin with packet. What is packet? In the simplest way, packet is a collection of data that can be used by computers which need to communicate with each other, usually as a part of a network. If you deep a bit if you dig a bit deeper, essentially zeros and ones are packed together based on time. So that's our packet. And second is frame. So frame consists of a sequence of bits or symbols that indicate the receiver, the beginning and end of the payload data within the stream of symbols or bits it receives. I will show you what is frame directly also. Okay, let's look into that. And then third one we have is a server. A server refers to the nerve center of any network. It typically needs to be much more high powered than a regular desktop workstation. So using environment variables name preceded by a dollar sign, we can tap into that server. So I will show one server also directly. How does it look? And then workstation. What is workstation? So workstation refers to each person's computer, your front end, so back office staff computers, and the machines in the examination rooms will all be called as the workstations, which are part of the network. So before we go to the other terminology, so let's look into the server first, and then we'll see packet, frame, all other network. So let me open putty. Okay, I will not tell you what this server is, which server, but it's a live server which are running now, and few applications using containerization and Kubernetes technique, we have deployed it as a microservice, and that application is running live and our clients are using it. Okay, that server I just want to access, and then I will show you. That's it. We are in the server. So this is our server. I'll become a sudo as soon as possible. I don't want you to look all those things. 1 2 3 4 5 6. Okay, let me clear the screen first. And now exactly we are in a server. This is not a PC, this is not a computer or something. It's a hosted machine with a more, it's a CPU. It consists of a RAM, hard disk, everything as a normal laptop, but it will be designed specifically for hosting the application. So in this we are hosting some specific application. I just want to so Docker PSC, these are the containers which are running, and then Docker images, these are the images which are there. So this is an example of this is the example of a server which is presently running. It's a live server, and the application which is hosted in the server is also running live at this moment. So now I would like to show system ctl status docker. So Docker is also active and running, and system. Okay, let me clear the screen. Yes, so that's how we install our services, and we host our application in the server. So that's what a server is, and this is how we log in. So let me exit. Yes, that's done. So that's our server. So now uh, let's look into what is a Cat5 cable. Cat5 cable. This term refers to category 5. Cat5 means a category 5 cable used when your network is hardwired. Now, what is hardwired? The next question would be, what is hardwired? Hardwired means that all the workstations in the office plug into a network outlet using a physical cabling to transport data to and from the server. That's what we call it as a hardwiring the network or hardwired network. Then we have to understand what is network interface. So network interface is a software interface to networking hardware. It's the uh, it's kind of a center point. It's kind of intermediary place where it's in between a software. uh, it's a software interface between the human and then other one. So basically, network interface is a software interface to the networking hardware. So for instance, if you have two network cards in your computer, you can control and configure each network interface associated with them individually. So that's what the network interface is. Then we have connection. Simply, connection refers to pieces of related information that are transferred through a network. That's what we call as connection. I'll show you that. And then a gateway. A gateway is a device that routes traffic between networks. For example, at home, your router is your gateway. I think everybody might have this router. So most of the people might have this router. So router is a gateway to your network, to the external network. So it provides a gateway between your LAN and then WAN. LAN is a local area network. WAN is a wide area network. It's a gateway between these two. So then we have a bandwidth. So bandwidth refers to a capacity of line. That's it. Bandwidth is nothing but the capacity of a line. Capacity of line. That means how much data that the cable or line can transfer through it. That's what the bandwidth is. So let's take one example. So here if you take, so 213 cleanwork.zip, this is an HTML static website which has been hosted in a proxy server, in a server. So the request URL, if you want to get it, this is the request URL you have to use, and this get method. So the address of that server is this 69.16.20.107.443 is the uh, port 1. It's a port. So this is the address of remote address of this application server. So now let's see response headers. What all headers, response headers are used in this? First one, the data is accepted in bytes, the range in bytes, and then content encoding is gzip. So content type is application or zip. So now date and expires and server type Apache. Basically, the server type that you can use or that existing server is Apache 2. That means the server is Ubuntu, and the service which they have used is Apache. So that's how the data can be transferred. This is some information, and then address of a server, everything we have seen. So now let's look into timing, just to get the better understanding of client and server and client model. So if you look into this, queuing point 3, stalled 0.12 millisecond. So request sent, so I have sent a request in 0 duration, and after that waiting for server response. It took almost 0.223 milliseconds. So server to response. So between the request sent and then server response, the time spent is 0.223 milliseconds. So then once the server gave a response, after that to download the content it took 3.22 milliseconds. Total duration is 3.93 milliseconds. So this fast the server has responded. So the request sent, then wait time, then the response is given. So that means within zero point 0.3 millisecond I got the response. So uh, the packets, the data has been transferred through packets only. And this is how a request and then a response works, and the client server model works. We have seen enough of basics. So now let's move into exploring various types of network uh, based on geography and based on different other ways, different other methods. So broadly speaking, there are two types of transmission technology that are in widespread use. So the first one is broadcast links, and second one is point to point links. Basically this is uh, types of transmission technology. One is point to point links, and second one is broadcast link or broadcast network. So first let us look into point to point links, and then we will move to the broadcast network. So what is point to point? So point to point is very simple. We have seen in our life almost all the time, even broadcast also we have seen. So point to point links, point to point link connect individual pair of machines to go from source to the destination on a network made up of point to point links. Short messages called packets in certain contexts. You may have to first visit one or more intermediate machines. Often multiple routes of different lengths are possible. So finding good ones is important in point to point network. So point to point transmission with exactly one sender and exactly one receiver is sometimes called as unicasting. Then the second type that we have here is broadcast network. So in contrast on a broadcast network, the communication channel is shared by all the machines on the network. The packets sent by any machine or received by the all others. So, uh, sorry, an address field within each packet specifies the intended recipient. So, upon receiving a packet, a machine checks the address field. If the packet is intended for the receiving machine, the machine processes the packet. If the packet is intended for some other machine, it's just ignored. For example, mm, if you take an example, a wireless network. A wireless network is a common example of a broadcast link. A wireless network, so how does it work? Uh, with a communication shared over a coverage region that depends on the wireless channel and the transmitting machine. As an analogy, consider someone standing in a meeting room and shouting, Divya, come here, I want you. So, although the packet may actually be received or heard by many people, but only Divya will respond. So, the others just ignore it. So, this is how it works. As the simplest example for the broadcast network. So, broadcast system usually also allow the possibility of addressing a packet to all destinations by using a special code in the address field. When a packet with this code is transmitted, it is received and processed by every mission on the network. So like when you want to call all, you say hello everybody, good morning to all. So when you address all the people who are inside the meeting hall will process your command. All the people who are in the meeting hall will respond to you, because that's the other way of doing. In similar way, in broadcast, if you use a certain kind of code, all other missions can also be processed at a time. So this mode of operation is called as broadcasting. It's a broadcasting. Point to point link will have a unicasting, whereas whereas at sometimes you can connect with all the machines with a one from the one machine. It's called broadcasting. So unicasting as well as broadcasting. So some broadcast systems also support transmission to a subset of machines, which we call it as a multicasting. So there is uh, one more way of dividing the networks. This is types of transmission technology. So now let's divide the network. Let's bifurcate the networks based on geography. An alternative criteria for classifying networks is by scale, by sheer amount of scale. The distance is the distance is also an important criteria, the important criteria, of course, but the distance is important as a classification metric or a criteria, because different technologies are used as a different scales. So this one, what we call it as a network classification based on scale. So if you see the following figure, which is displayed on the screen, we classify we classify multiple processor systems by their rough physical size. At the top are the personal area network. What are PAN, what is personal area network? Networks that are meant for one person. So interprocessor distance approximately 1 meter, and processors located in the same, basically around a square meter of a distance. Approximately, it's not a hard and fast rule. It's approximately, if it is with a interprocessor distance of 1 meter, and then if processors are located, all the processors which are part of personal area network, if they are located in and around of 1 square meter, we call it as a personal area network. Beyond these come longer range networks. These can be divided into local area network, metropolitan local areas network, and then a long range one, a metropolitan and wide area networks with increasing scale. So local area network, and then metropolitan area network, and then wide area network with an increasing scale. So then finally, the connection of two or more networks is called the internet. The connection of two or more networks together is called the internetwork. The internetwork. The worldwide internet is certainly the best known but not the only one example of an internetwork. Soon we will get more uh, different types of internetworks. So at this moment, the most famous one and then widely used one is www. That's a worldwide network. Okay, so here on the screen you can clearly see the inter-processor distance and then processors located in the same room. If they're located in the same room or same building or same campus with 10 to 1 kilometer of distance, we call it as a local area network. If the processors are located inside the city, we call it as a metropolitan network. If it is from the country to the continent, we call it as a wide area network, WAN. If it is across the planet, in that case we have to connect each one network with the another network, like you have to connect a wide area network with the metropolitan area network. Then this kind of internetworking, this kind of connecting with each other network is known as the internetwork. It's called internetwork. So soon we will have even a larger internetworks with the interplanetary internet that connects networks across the space together, across the space. So in the following sections, what I will do is I will give you a brief introduction to network hardware by scale. So we are going to explore each type of network in our forthcoming slides. Step up is the local area network. That's LAN in shortcut. So LAN is a privately owned network that operates within the within and nearby a single building, like a home, office, or factory. So LANs are widely used to connect personal computers and consumer electronics to let them share resources. The best example is a printer and exchange information. So when LANs are used by companies, they are called as enterprise networks. Now let's begin with the first one. There are two types of LAN. The first one is wireless LAN. Wireless LANs are very popular these days. Everybody might use this, whether they do know about this wireless LAN or not, but they might have experience and used wireless LAN some or other day in their life. So especially in homes, older office buildings, cafeteria, and other places where it is too much trouble to install cables. In this kind of in these systems, every computer has a radio modem and an antenna that it uses to communicate with other computers. So in most cases, what happens, each computer talks to a device in the ceiling. I'll just show it. So here, this is the wireless LAN. So wireless LAN IEEE 802.1 is actually called as Wi-Fi. When you say Wi-Fi, we are talking about a wireless LAN. Okay. So what happens, in most cases, each computer talks to a device in the ceiling. So that I'll show it in a figure. So that is called, this device, what we call it as an access point. This device is the main important aspect of Wi-Fi network. So that is called an access point, or simply AP. So an access point, wireless router or base station. So it relays packets between the wireless computers and also between them and the internet. So being the access point is like being the popular kid at school, the popular kid in school, because everyone wants to talk to the popular kid in the school. So access point is like that. Every computer likes to speak to access point. So however, if the other computers are close enough, they can communicate directly with one another in a peer-to-peer configuration. So this is how our Wi-Fi network works. So there is a standard. There is a standard for wireless LANs. That standard is called as IEEE 802.11. So popularly known this wireless standard LAN IEEE 802.11 as Wi-Fi. Wi-Fi, which has become very widespread. Uh, it runs at speeds anywhere from 11 to 100 Mbps, 11 to 100 Mbps, and this access point or router would be connected to the wired network. So this is how a wireless network or IEEE 802.1 standard is known as Wi-Fi works. So this access point or the router will be connected to the wired network, and then from this access point, all other wireless computers would try to connect or speak to this access point. So that's our wireless LAN. So now let's move into wired LAN. So wired LANs use a range of different transmission technologies. Most of them use copper wires, but some use optical fibers. So optical fiber is in widespread and it's widely used. And optical fiber runs at speeds anywhere from 11 to hundreds of Mbps. So hundreds of Mbps. So case transmission time is bounded and known in advance. So knowing these bounds help us with the task of designing network protocols. Typically, wired LANs run at speeds of 100 Mbps to 1 Gbps and have low delay. So delay could be microseconds or nanoseconds and make very few errors. So that's the speed of a wired LAN, wired local area network. So newer LANs can operate up to 10 Gbps. So compared to wireless networks, wired LANs exceed them in all dimensions of performance. So it's just easier to send signals over a wire or through a fiber than through the air. So for a wireless network, you have one, two, and and then a third PC. So all three PCs are connected. So the topology of many wired LANs is built from point to point links. So it's not broadcasting. So it's a point to point link, whereas Wi-Fi wireless LAN is our broadcasting, and this one is point to point links. So here IEEE again 802.3 is the standard for the wired LAN. So popularly called this as Ethernet switch. Ethernet switch. So or simply these wired cables, these optic fiber cables that we connect with the PC with that standard IEEE 802.3 are known as Ethernet. Ethernet. So Ethernet is by far the most common type of wired LAN. So this is how a wired LAN topology looks like, and this is how a wireless LAN topology looks like. If you look into this picture, so wired LAN, three computers are connected with Ethernet switch through Ethernets. So it's a sample topology of switched Ethernet. So each computer speaks the Ethernet protocol and connects to a box called a switch with a point to point link, a point to a point link. Hence the name. A switch has multiple ports. Here we have multiple ports, each of which can connect to one computer. So the job of the switch is to relay packets between computers that are attached to it. So using the address in each packet to determine which computer to send it to. Let's look into PAN first. That's personal area network. So a personal area network lets devices communicate over the range of a person. So we have taken an interprocessor distance of 1 meter uh, and a area of 1 square meter. So that's the approximate distances and areas that we have considered. So basically this kind of network we call it as a personal area network. A common example is a wireless network that connects a computer with its peripherals, that I'll show you on the rightmost portion of our screen. So, and second one, almost every computer has an attached monitor. Yes or no? Of course, without the attached monitor, how can you see my video? Of course, you are watching my video through the attached monitor, or maybe attached or maybe um, uh, or maybe some other display or some other way. And you will have a keyboard, and you will have a mouse, and you will have a printer without using wireless. So these are all wired ones. So this connection must be done with the cables. If not, so later, to help these users, some companies get together to design a short range wireless network called Bluetooth to connect these company components without wires. That's what. Now I'm using a mouse which is wireless, which is connected through Bluetooth. I'm using a speakers which is wireless, which is also connected to Bluetooth. I take Wi-Fi from my mobile phone. So I use some other tools which are Bluetooth. I use a mic which is Bluetooth. So that's how a short range wireless network called Bluetooth. Bluetooth is basically a short range wireless network. Okay, this makes the PAN personal area network possible. So let's look into the personal area network which is in and around of your computer. So Bluetooth PAN configuration, that's very important. And then this is the example. So you have your personal computer in front of you. Of course, uh, now even keyboard. My keyboard is itself. My keyboard is also wireless. It's also connected through Bluetooth. Other than CPU, CPU is wired. It's connected through the cables. Other than that, rest all mouse and then keyboard are connected through Bluetooth. Then we have a mic. A mic is also connected through Bluetooth. Then we have speakers. Speakers are connected through Bluetooth. Then we have game stick, and then that is also connected through Bluetooth. So all comes under a personal area network, and all these tools are in and around uh, of a 1 square meter area. You can see that they are playing around. So PAN is a small network established for communication between different devices such as laptops, computers, mobiles, and PDAs. PDA is nothing but PAN personal devices which are in and around our areas. And then a PAN may include wired and wireless devices, but it's a personal area network which is in and around of of an area of 1 square meter. Look into a much bigger network, that is Metropolitan Area Network. Man Metropolitan Area Network. So man covers a city, covers an entire city. The best known examples of MANs are the cable television networks available in many cities, maybe in your city too. So these systems grew from earlier community antenna systems used in area with a poor over the air television reception. In those early systems, a large antenna was placed on top of a nearby hill, and a signal was then piped to the subscribers' houses. That's what the earlier man network, that was only relied on a huge antenna which was put on a top of a nearby hill. At first, these were locally designed ad hoc systems. Then companies began jumping into the business, so getting contracts from local governments to wire up entire cities. The next step was television programming and even entire channels designed for cable only. So often these channels were highly specialized, such as all news, all sports, all cooking, all gardening, and so on and so forth. But from their inception until the late 1990s, they were intended for television reception only. But but when the internet began attracting a mass audience, the cable TV network operators began to realize that with some changes to the system, they could provide a two-way internet service in unused parts of the spectrum. At that point, the cable TV system began to morph from simply a way to distribute television to a metropolitan area network. To a first approximation, a man might look something like the system that I'm showing on your screen. That's, I think it's displayed on your screen. It's visible clearly for this. So you will have a big antenna. Let's remove this internet for the for this moment. If you keep this internet out and if you see the another if you see the layout together, so then it's called a traditional television network, a big antenna, then head end, and from there the subscribers will be connected with the line. But now the things have changed, internet is also included, so now it is not a one way, it's a two way. It can send as it can receive as well as send the signals. So here we have antenna, it takes it receives from antenna and it can send through internet, also it can take through internet. So then at the city we will have a junction box to every street, junction box 1, junction box 2, junction box 3, and from each junction box the street houses will be connected with the cable wires. So if you see this figure, in this figure we see both television signals, that's from antenna, and internet, that's from uh, optic fiber, being fed into the centralized cable, or centralized cable, that's a head end cable, head end for subsequent distribution to people's homes. So in this figure, we see both television signals and internet being fed into the center part. You can see that. So both from antenna as well as internet, and all things will be fed into the system. So if you want only internet, basically you can fetch it from head end. If you want both television services as well as internet services, still you can fetch it. So this is the recent, it's not the recent one, this is the new development. And in spite of going for the traditional, now these cable TV network operators have used the new way of doing things. So cable television is not only the man. Through recent developments in high-speed wireless internet access have resulted in another man which has been standardized. So because of this, it has been standardized as IEEE 802.16 and is popularly known as WiMAX. So we have seen three standards so far. One is IEEE 802.11, that is Wi-Fi, that's a LAN standard. Then we have seen IEEE 803, just a minute, 802.3. IEEE 802.3, that's a switched Ethernet, that's also of a LAN. And one more standard that we have just seen is IEEE 802.16. It is now popularly known as WiMAX, and it's used for the cable TV or basically man, metropolitan area networks. So we are now in a position to look at two other varieties of wide area network. First, rather than lease dedicated transmission lines, a company might connect its offices to the internet. That internet allows connections to be made between the offices as virtual links, so that use the underlying capacity of the internet. You can see the arrangement that is displayed in front of your screen. So this arrangement is called as virtual private network. Virtual private network. In spite of your own subnet, in spite of your own transmission line, in spite of your own routers, you can lease out somebody's subnet, somebody's router, somebody's transmission lines. So uh, you can actually use it, their subnet. Basically, the same subnet. can be used by somebody else also. This concept is called virtualization. So compared to the dedicated arrangement, a VPN, that is virtual private network, has the usual advantage of virtualization. So which is that it provides a flexible reuse of a resource through internet connection. So what is virtualization of subnet? Virtualization in computing resources. See, virtualization in computing resources is you will have your computer. So your computer might have 1 terabyte hard disk and 16 GB of RAM. So now, in spite of using it as a single computer, you can virtualize your computer and you can create a virtual machines inside your computer uh, virtual tool, virtual box, using Oracle VM box or any VMware. You can use any virtual machineWare and then you can create a. So basically, your resource is one, but you can create 3 4 virtual machine, and these virtual machines can be given or rent out to other people. So the same logic works here. Somebody's will own the subnet is obviously nothing but transmission lines and routers. That subnet will be owned by somebody else, whereas he will virtualize the subnet. When you virtualize the subnet, that's what we call it as a virtual private network. So that VPN, that virtual private network, can be rented out or leased out to the people who wants to use. So the benefit, what's the benefit here? Consider how easy it to add a fourth office to see this, because a VPN also has the usual disadvantage of virtualization, so which is a lack of control over the underlying resources. With a dedicated line, what's the problem? The capacity is clear. With a VPN, your mileage may vary with your internet service. That is the biggest negative point of pain point of VPN. That's a virtual private network. Whereas the biggest positive point, the biggest brighter side of VPN is basically you are sharing the resources. You have to pay or a part of the resources. That's it. You don't need to take a big capital, and lot of investment is not required to be done. And if you want to add one more office, still it is not that much investment is required, because you have to invest only for from your point of view. Subnet is owned by somebody else. They will take care, they will charge a bit more as a subscription. That's it. So it's similar to a cloud services that you are using, a virtualization. Here, a computing resource virtualization, you are virtualizing the hard disk. There you are virtualizing the subnet. So that's the only difference, rest all same. So let me get into the AWS, and let me try to show this also. So let's take one example. Again, we'll take Asia Pacific Mumbai. So it has a one virtual private cloud in this area. So if you want, you can create many more. So let me type VPN. So that is our virtual private network. So we can do it through VPC. So you have to click, you can use a VPC service. So let me click on this VPC service. So network is pretty slow here. So that's the reason it's taking so much of time. So just bear with me. Sorry for the inconvenience from my side. So here it is, a VPC service. So now it is asking, so resources by region. VPC. In US East, you have one VPC and 6 subnets, and then round tables, internet gateways. These are all elastic IPs. These are all related to this, but for us, VPC is more than enough. That's what we want to say. Let's click on VPC. Anyway, we are going to create our own VPC in our. So this one, I just want to add it. Okay. This is the reason US East. Okay, it's in North Virginia. That's fine. So now if you want to create your own VPC, just click here and you type your name. name of the VPC that you want, and then give a protocol, that IP, internet protocol address, then tenancy, and then tags. So now when you create a VPC here, what happens? It literally does the same thing, virtualization of the, so now it is in North Virginia, right? So in North Virginia, let me get back to the, so now we are in North Virginia. In North Virginia, how many subnets are there? That's what we are going to check now. So it's still loading. Yep, it has come up. US North Virginia, North Virginia. Here it is. So North Virginia has 6 subnets. It has one VPC, 6 subnets. Now we have 6 subnets, out of which when you create a virtual private cloud, it will select 1 or 2 subnet, any one subnet it will select, and then in that subnet it will create a separate virtual private cloud. That means it's literally virtualizing a subnet. That's what is happening. So we are taking the services from that. This is how a virtual private network, a VPN, works from actual subnet. And these are the benefits that we have, as so far we have discussed. So if you want to have a quick view on what are things will be attached to the subnet. So this is the subnet ID, and then it will have a IP, internet protocol, and then network border group and subnet ARN. This is very important. A reference number. This is very important when we go to the Kubernetes. We will use this, and then IP version 4, and availability zone is also very important when we deal with the this thing. And a route table is the one in this subnet. It the route table is the one which actually route the requests, and that comes into this subnet. So route table is very important. Let me click on the route table and show it to you. Yeah, this is our route table that we have. So it's a route table ID, and this is where the route table has been stored. And one more point to be added here is a virtual private network. So in virtual private network, the subnet can be yours or can be the third party also. So in virtual private network, if it is your own subnet, still it will be virtualized. Still it will be virtualized, and there you can have more than n number of private networks. So now we will look into the second variation. The second variation is that the subnet may be run by a different company, maybe. So the subnet operator is known as the network service provider, and the offices are its customers. So you can see the structure in the figure, the infographics that is displayed on the screen. The subnet operator will connect to the customer, will connect to other customers, to not only this customer, to other customers too, as long as they can pay and it can provide service. If the customers could only send packets to each other, the subnet operator will also connect to the other networks that are part of the internet. So how this network works, makes the decision as to which path to use is called the routing algorithm. So many such algorithms exist. How each router makes the decision is a decision as to where to send a packet. Next is called the forwarding algorithm. Based on this routing algorithm and that forwarding algorithm, the all things takes place. So basically this, the third part, is WAN using ISP network. Here it's completely the internet service provider enters into the game. So what you have to do is you just take the subscription from any internet service provider. That's it. Rest all will be taken care by them. This is ISP, internet service provider. Now let's look into few other types of wide area networks. So the first one is satellite network. So what is satellite network? In satellite systems, each computer on the ground has an antenna through which it can send data to and receive data from to a satellite in orbit. And I'm not going in depth for the satellite network and cellular telephone network, because these are not the most important topics for us. I just want to take a quick round of this satellite network and cellular network and internetworks. Okay, so normally a satellite network will have one computer on the ground, and it will have an antenna, and then this will send a data, and you will have one more satellite that's rotating in the orbit. Now all computers can hear the output from the satellite, and in some cases they can also hear the upward transmissions of their fellow computers to the satellite as well. So now satellite networks are inherently broadcast. Obviously, they are broadcast and are most useful when the broadcast property is important. So this is one type of wide area network. It's a satellite network. And on other side, we have cellular network, cellular telephone network. So what is cellular telephone network? The cellular telephone network is another example of a wide area network that uses the wireless technology. So this system has already gone through the four generation 1G, 2G, 3G, and now 4G. Now in India, Modi government has been rolling out 5G. In Bengaluru, we are getting a huge amount of 5G for the free of cost. Let's hope we'll get for more days. So, and the fifth one is on, it's not just the fifth one is basically is rolled out by end of this year 2023. They are going to completely roll out the 5G in India. The first generation was analog and for voice only. The second generation was digital and for voice only. And the third generation is digital and is for both voice and data. That is 3G. From the 3G, the third generation, we started experiencing the data. We started experiencing the data. Before that, it's just voice. That's it. So then a wireless. Now the fourth will have both and the voice also through data only, and the fourth and finally we are entering into the 5G with very high speed, the damn speed. It's 1 GB. 1 GB per second is the normal speed that we are getting as a 5G. So a wireless LAN, a local area network with a range measured in kilometers rather than tens of meters. So base stations are connected to each other by a backbone network that is usually wired. So the data rates of cellular networks are often on the order of 1 Mbps. So much smaller than a wireless local area network that can range up to on the order of 100 Mbps. So now let's look into internetworks. A collection of interconnected networks is called as an internetwork or just internet. Internet. So not normally when people say internet, they think it is Airtel. They think it is Geo. They think it is some other network. They think it's Vodafone Idea. No, that's not the internet. Internet is the one which interconnects different networks. And what does internet do? Internet that we use, it may be Airtel or Geo. It connects a wide area network with a local area network. So that's the reason we call it as a internetwork. In short, we call it as a internet. So these terms will be used in a generic sense in contrast to the worldwide internet, but that's not the case. So which is one specific internet. That's it. It is one version. It's one version of internet, but you can have n number, which we will always capitalize. So the internet uses ISP, internet service providers networks, to connect enterprise networks, home networks, and many other networks. So let's also define what is subnet and network and internetwork one more time, to have a clear cut understanding and to get the clear cut differentiation, to make a clear cut differentiation between the each words. Okay, what the subnet, the term subnet makes the most sense in the context of a wide area network, where it refers to the collection of routers and communication lines owned by the network operator. That's it. That's what the subnet is. A subnet is the collection of routers and communication lines owned by network operator. Okay, and then what is network? A network is formed by the combination of a subnet and its hosts. However, the word network is often used in a loose sense as well. A subnet might be described as a network, as in the case of the ISP network. So then we will look into internetwork. Internetwork. We know that an internet is formed when distinct networks are interconnected. In our view, connecting a LAN and a WAN, that's a local area network, and a wide area network are connecting, or else connecting two local area networks is the usual way to form an internetwork. But there is little agreement in the industry over terminology in this area. There are two rules of thumb that are useful. First, if different organizations have paid to construct different parts of the network and each maintains its part, we have an inter-network rather than a single network. Second, if the underlying technology is different in different parts, example broadcast versus point to point and wired versus wireless, we probably have an inter-network. So the general name for a machine that makes a connection between two or more networks and provides the necessary translation, uh, both in terms of hardware and software, is a gateway. That's it. Gateway is that simple. The gateway is, it's a general name for a machine. It could be a computer. It could be a computer with an application who which manages, which provides the necessary translation, both in terms of hardware and software, to make a connection between two or more networks possible.